Blender is an animation program, a full-featured one that is very similar to others that you might have heard of, like 3D Studio Max or Maya or Modo or Cinema 4D. Full-featured, it has modeling and sculpting tools like this sculpt made by a friend of mine called Kfir. Also texturing and shading, lighting, rigging and animation, lighting and rendering. It actually has two rendering engines. One is called the Scanline engine. It's a simple one for stylized graphics, and the other is a photorealistic path tracer called Cycles, a newer one. There are also compositing and video editing tools, a game engine, a full-featured game engine with logics and scriptability, camera tracking and green screen VFX tools, simulations like cloth, fluids, smoke, particles, and bolt physics. And the difference between Blender and most other animation packages in 3D is that it's free and open source. The thing I'd like to focus in this talk, obviously, is Blender's Python API. So Blender has a Python API that allows you to create custom tools, perform automation of manual tasks, and write scripts that also enable you to access the full range of Python packages out there. We do that mostly using one library within Blender called BPY, or Blender Python, the Blender Python module, and it allows you to access scene data. Scene is actually the collection of all the objects that you animate within the program, so all your models and light sources and textures and whatnot, and animations and rigs. So you can access them through the BPY module. You can also manipulate and generate objects within the scene. You can emulate UI commands. So let's say you want to automate something that an animator or a modelist usually performs by hand. You can access the UI commands and automate that. You can also load and export assets, and you can create new menus and panels and add-ons with either the existing or new logics and operators. So if you want to help animators, customize their UI to make things more efficient for them, you can do that as well with BPY. But there's also a few other modules that you can import within Blender that can help you do other stuff like bmesh. Bmesh is a more recent module that is very efficient for the manipulation and creation of what's called polygonal meshes. Polygons in 3D are objects that are comprised of three main types of elements: vertices, edges, and faces. And most of what you know of and have seen from 3D printing or games, they use polygons most of the time. There are other types of geometry that you can work with in 3D, like NURBS and other surfaces, but this module helps you work with meshes. There's also the BGE module. That's the Blender Game Engine module that allows you to write complex logics for the game engine and interactive experiences in general. The BGL, the OpenGL wrapper. Blender allows you to work with an OpenGL viewport, and you can actually add some functionality to it through this one. There's BLF for also with the OpenGL module showing text, so enhancing the UI with text. And there's mathutils, which is a specific module for vector matrix and geometry functionality. It's very efficient. You could actually import it for any of your other projects. It gives you access to very simple and very nice vector math and matrix math without you needing to do any linear algebra by yourself. So it's really nice. There's actually a lot more going on here that I haven't mentioned. These are just some of the more commonly used modules. So this is going to be a very practical kind of introduction to this topic, and I have some examples that I'm going to show you, and you can find them in this GitHub repo. This presentation is going online, so you'll be able to watch it later. So in this example, we are going to actually generate cubes, 50 cubes, randomly in 3D space. So let's go over the code, and then we'll see this within Blender. So the first thing we do with this script is going to import the BPY module. BPY is something that you can import when you write a Blender script and you run it within Blender. So once you import it, you have access to everything underneath that module, that library. And we're also going to import the randint, the random integer function from the Python standard module of random. So something that this is a good opportunity to mention is that Blender actually uses its own Python that's bundled within Blender, but this is a standard Python, so you can import any standard Python library, and you can also install any non-standard library. Sometimes causes some trouble, and you can also find easy solutions to that, which I'll mention later, but this is a standard module, so we're importing just a rand int. Then we want to generate just 50 cubes in random locations. Of course, we're going to iterate over 50 instances with a range function, and then we're calling an operator. So here I'm going to just jump into Blender, and I want to show you how it works here within Blender. So I'm just going to really quick copy the same commands. Oops, don't want to be in caps lock. So this is Blender. We have the 3D viewport here. We have an an interactive console for real-time typing of commands right here. And this is a text editor, which I can just launch scripts within. So I did a quick setup of the UI, and when you get into that, you find that it's not difficult to do this setup. It's not the default way that Blender loads, but it's not a complex thing either to do. Just going to put syntax highlighting on. So then we have from random import rand int, and now we are going to go do this for I in range 50. As I said, I'm calling actually an operator. I'm accessing BPY. So what is this? Okay, so BPY gives us access to a wide range of things within Blender. If I go to the interactive console where I have auto-completion, I type BPY dot, and then if I go and press control space, I can see that I get a whole lot of stuff here. I have the app commands, the context, data, ops, path, and other stuff. So I'm accessing the ops collection here, which is the collection of operators. Operators are all the commands that Blender holds within, and actually all the UI commands are operators as well. You can see that the operators are also divided into various categories, lots of categories actually. What we have in the example here is a mesh operator that I'm launching. So it's a mesh operator because we are generating a mesh cube. So I'm gonna get into the mesh, and inside mesh we have again various kinds of operators. So the operator we're going to launch is called the primitive cube add. A primitive in 3D is a simple object, a simple shape that you start with usually, and you usually build on it. But we have a few different primitives here. So there's a circle and cone and cube and cylinder and grid and other shapes. We want to add a cube. And this operator has various parameters, which we're not going to address. Actually, in this script, we are going to address a specific parameter only, which is the location. Let's get back to the presentation. So what I'm doing here is actually generating 50 cubes. I'm calling the primitive cube add operator 50 times, every time with a different location that is randomly generated. So we have a rand int between -10 and 10 for each of the 3 axes in 3D, X, Y, and Z. Okay, it's very simple. So let's repeat that here. So let's give this a little bit more space so I'll be able to read a little bit more comfortably. And then all I need to do is just run this script. So I'm gonna press run script here, and we have 50 randomly place cubes on 3D space. Okay, so that was a very simple example. Let's try and go to another simple example, just with, again, for generating cubes. But this time we're going to generate cubes along a sine path, a sine curve. So we're importing BPY again, and this time we're going to import from the math standard library the function sin for a sine. Let's do that right here. So I'm going to replace the rand int with importing sin. And then again we have 50 cubes, but this time I'm going to give the XYZ values. So all the cubes are going to have an X value of 0 and a Y value of I, which is the current iteration number, and the Z, which is the height. In Blender, the Z axis is the height axis, is going to be the sine value of that I that we are currently iterating over. Okay, so let's try that. Okay, and now the location is going to be just X, Y, and Z. All right, so if I launch this, I get cubes along a sine path or sine curve. And they're quite tightly packed. They're actually one inside the other because a standard cube has a size of 2 units. So if I want to space them out a little bit, I can just add or a step where just I'm going to double the y value and maybe the z value as well. And then we have slightly larger sign list of cubes. Okay, so those were two very simple examples. Let's just see them right here. Let's go to a slightly more complex example, again with a sine curve, but this time we are going to generate a mesh. So instead of just a bunch of cubes, we're going to generate a specific curved mesh. So this is going to be slightly more complex, though not by much, and I'm importing NumPy here for a very simple function from NumPy, and we are going to see an example that doesn't require NumPy as well, because probably NumPy is not installed here, at least not in Blender. So let's go over a slightly more complex example. Okay, so now, as I said, I don't want to just create random cubes or cubes aligned on a path. I want to generate a whole new mesh. So mesh, as I said, has three types of elements. It has vertices, which are points, and it has edges, which are the lines connecting the vertices, and it has faces, which we're not using here, but faces are the thing that encloses the mesh within a shell. So a cube, for instance, if we go to Blender and add a little cube, a cube is a mesh that has it has 6 faces because it's a cube, and it has 8 edges and 8 vertices. Okay, so these are the vertices, and there are faces and edges. So we are going to generate 100 vertices. So the way we do this is we actually go, and after we generated a new mesh, and how we do that, let's go over this for a moment, just so everything is clear. Again, we're accessing BPY, but this time we're going to the data collection, which you can see here. Let's go to the interactive console again. BPY data has lots of stuff, so it gives you access to everything within the scene. So there are the screens of the UI, and there are the objects, and there are images that you might load as textures or use for anything else, curves and cameras and brushes, and also meshes. So BPY data meshes, that's what we're accessing here. And we have a new function to create a new mesh, and it returns that mesh right here to this reference M. Now we have 100 vertices that we want to create, so we access the mesh within M and go to the vertices collection. Because it's a mesh, it already has a vertices property or collection, and then we call the add method with the number 100 to add 100 new vertices. And then we also want to add edges, but in this kind of a line, we need one less edge than the number of vertices we have, or n-1, so we create 99 edges for the 100 vertices that we have. And then what we're going to do is actually, we want just to have the y value on the y-axis. We just want to have evenly spaced values between 0 and 10. So I just used the NumPy linearly spaced values function here. Of course, we don't have to use this one, and I'll probably show an example in a second that doesn't use linspace, but uses just a function that I wrote, and we get all the y values here, 100 y values for this list. And then we iterate over those, and this is kind of a silly way to use zip here. I could probably have used enumerate, but never mind, this is going to work. And we just have I that is the number of iteration, the current iteration, and y, which is the y value. And then we go over each and every vertex within the vertices collection, and we give the coordinate value this following 3 values. So for x, all vertices get a 0, and y, we use the linspace values here, and then we use just the sin, or for the sign value of y. Because we don't want to have, we want one less edges than the number of vertices, I have a little conditional here. So if I is just not the last one, everything but the last value here, we also give the edge the vertices that we want, which is actually the current vertex and the next vertex in the list. Okay, so I and I plus 1. Then we just need to create an object. So why do we create an object? Blender is very efficient, which means that if you want to manipulate meshes, you can do this virtually without seeing the mesh in 3D space at all. So it can just be a collection of data, just like with any script that is not 3D. And if you actually want to see your mesh, you need to link it to your current scene as an object. Okay, an object in Blender is anything that has a number of specific data types. So it could be a light source, it could be a camera, it could be a mesh, it could be a curve, it could be various things. So I'm going to create a new object. I'm going to call it sin, and it's going to get the mesh data. And then we just link this object to the scene. And let's load this script here and launch it. So this is one without NumPy. Actually, the only difference is that I just wrote a linspace method here that does the same thing as a NumPy linspace, but the rest is the same. And you have more comments here, so you can read this at the GitHub script. And what we get here is this curved mesh. Okay, so it doesn't look like much because it doesn't have any volume. We can use some of Blender's modifiers. Okay, modifiers are subprograms that do various kinds of stuff to give it depth very quickly. For instance, we have the skin modifier that already gives it some depth. Then we can add some other modifiers to do all kinds of other stuff, like the subdivision surface, so it could be just look a little bit more curved and nicer. And of course, these two steps that I just did could be automated very easily. I just didn't want to go too much depth with a very introductory script. But this is very simple to do in this script as well, add these two modifiers. So what I'm going to do, I'm just going to continue some of my examples until I run out of time. So let's see another example. So here, what we're doing is actually, I'm going to just skip to the slightly more complex version. What I want to do is I want to import a CSV file and generate a 3D chart from it that is also going to be animated. So it's actually going to do this. Every one of the bars within the values in the CSV is going to just rise up. This is a real 3D chart, not like in some other apps that you might have generated 3D charts with. And it also has a date. So let's have a look at this, this CSV. So the CSV file looks like this. Let's just open it. And okay, so it looks very simple. It has dates and sales and simple integer values. That's the CSV file. I'm not actually going to open it because it's not that interesting. But what I want to do, I'm going to go to Blender and load the script. So we have CSV to Blender. And I'm just going to change the path here. So let's run this, and then we'll go over the code. I'm going to run this, and let's see if it works, or I made some issues. OK, so we have this little chart from the CSV. Let's go full screen. And if I launch an animation, we'll see that these bars actually animatively move with the animation. So let's see how this works. Okay, so first I'm importing BPY, of course. BPY is our basis for most Blender scripts, and then CSV. And then what I'm doing is importing the radians function, because rotation in Blender is usually in radians, not in ordinary degrees. And then we have a file path for our CSV. We're opening it with a CSV package, CSV file. And then because I really don't like CSV, actually, the CSV package, I'm just going to generate this into a list of data. So we have this data list with this little list comprehension. And I'm omitting the titles. Okay, so this starts from 1. This is why the slicing here is performed, to just ignore the titles. And this little line here just summarizes the sales so that we can have a total number of sales, a total count of the sales that we can then normalize our sales with accordingly. Okay, so we have a few little parameters here that control the animation that you just saw. Okay, so the duration is the number of frames for the scaling operation. Scaling is the change in size that you see here for each one of the bars. It takes 20 frames. Okay, that's just the duration. Okay, it's the interval between the start and the end of the animation. And then the interval between animations, so between one bar and then the next bar animating, is 5 frames. Okay, so that's this value. And then this little, we just iterate over each row in this list, which one row has a date and then a sale value, an integer sale value. For each one, what we do is this. We have a sale height. The height is the height of the cube that we're going to generate here in a second. So what we're doing here is we are dividing the current sale by the all sales sum. So this is just a simple way to normalize this value so we can have relatively easy to see differences between the different bars. And then you've seen this operating before where you're generating a new cube for every one of those sales. And its radius, meaning the general initial size, is a half unit in Blender. And then we're just placing the location here. So the location is set to be on the x-axis, one next to the other, with a difference of 1 Blender unit between each cube and the other cube and the next cube. So that will be this one, and 1.1, because I just want a little bit of spacing between them. They all start on the 0 y value, so they're all aligned on the y-axis, and then z is their height. I'm not going to go over this in too much detail. You can examine this in the Blender, in the repo on GitHub. Generally, what we do here, I'm going to go over to stuff we haven't seen before. So another thing that you can do is generate animations in Blender programmatically. So I'm actually doing something that is called inserting a keyframe. Okay, keyframes are a way to animate that doesn't require you to set values for each and every frame in your animation. So instead of you like starting and setting this pose and then slightly different and slightly different and then slightly different, what you do is you have one pose and keyframe it, and then the second pose keyframe the other one, and you have an interpolation that automatically moves between the two. Okay, so that's a keyframe. We're inserting it here, updating the scene, and then just generating some text. So I'm just going to leave it to you to examine. Just wanted to show this as something you can do. And you can see this, the entire code here is just, let's see the number of lines here, just 50 lines. So it's not complicated to do this. You just need to get familiarized with the Blender API a little bit. Some things that I want to just mention about this whole thing that are tricky, and you need to be aware of those when you write Blender scripts. One is that you can use UI operators, which is very convenient when you're trying to emulate what you do manually, but there are lower level solutions usually to everything in Blender. So it's not always the most efficient way to emulate what the user is doing through the UI. Usually you can do things in a lower level directly within the script, so it'll be more efficient. So that's one thing to note. The other thing is that some operators need a context. So for instance, when you want to open an image in Blender and use it as a texture, you can call an operator that operates within the image editor. So it's a window within Blender. And if you try to run this operator outside the image editor, it's going to fail because it will tell you the context is incorrect. I'm supposed to run within the image editor. You can override that, and you can do other stuff, or maybe you can just add the image in a lower level way, but this is something to be aware of. Also, not all UI elements are accessible through Python. Some of them are actually written in C++, and you don't have access to them directly when you want to automate them, so that's something to be aware of. Most of them are, but not all. There are also something called model operations, so a script to run very efficiently freezes the UI. So when you launch a script, Blender is not going to respond to your mouse or keyboard at all until it's finished. Unless you write something that's called a model operation. It has a mode, so it has a mode for waiting and a mode for getting input and then a mode for running. So you can do that, but it's not the default way a script runs, so just need to be aware of that. There's also view-dependent operations. For instance, I can cut a mesh from where I'm looking at it through the camera. I can, for instance, look at this cube from this direction, and if I cut it, it will be cut in this kind of way. But if I look at it from here, it will be cut differently. So that's view-dependent. And sometimes you need to set the view before you run an operation. And another thing that's tricky is that the API changes rather fast, and you need to be aware of that. Sometimes a function, it's usually backward compatible, but sometimes it won't be. And sometimes you need to just change something or add a parameter. So that's something that's also important to know. So if you want to start and get into this, There's the official documentation within the blender.org website, which is pretty nice and pretty detailed, not always, but most of the time. And again, a nice development environment is Blender itself that has this interactive console and the script editor right here. But of course, you don't have to work with it. You can work with other sources or other IDEs. You can also compile Blender as a Python library and just import it to your Python script. And you can set up Eclipse for debugging in real time with breakpoints and anything you want. It's a little bit tricky, but it's not too bad, and you can do that. There's a link here for doing that. There are good resources out there, like the Blender Stack Exchange page. This is a really active community. There are amazing people there. I got answers in less than 30 minutes to really complex questions before, so it's really helpful. There are good blogs. There's actually my blog here as well if you're interested. And there's this little code snippets page which has a lot of practical examples. So if you want to go and have a look at some more complex examples, there's this nice little audio visualizer. You import an MP3 file and it generates an audio visualizer, so it moves with the music and you can create cool animations that respond to your audio file. And there's a few scripts in my GitHub page that you can explore, like this spiral generator and lots of other stuff. And of course, since Blender is open source, you can actually, of course, write directly in C++ and do whatever you want. And this is rather rare. I've been writing Blender scripts for several years now, and it's really rare that you really bump into something that is not accessible through Python. It's usually something like a very special kind of UI element in a specific window. And usually you don't need that. You can do stuff in different ways. But if you really have to, yeah, you can access it in C types or just write directly to the source. Additional questions? Yeah.
About UI, and what about web UI?
Web UI. Okay, so there's various ways to do that. Actually, one way to do that, there's a nice project called Blend for Web that allows you to take a Blender scene and actually generate a web view from that, an interactive web view where you can do all kinds of cool stuff. It's based on WebGL for the web, and it's actually, if anybody here is familiar with 3JS, the library in JavaScript for 3D in the browser, it's an alternative to that, and it's really integral with Blender, so you can generate dynamic views or even games rather easily from Blender and generate it on the web. So that's one way to do that. Any other questions? Okay, thanks very much.